Hello and welcome to math class. Today we are going to start chapter 3. It's about ratios, as you can see right here. Ratios, remember, are two numbers. We've done a lot with ratios in our Math 5 a day, so hopefully this lesson won't be too challenging. So it says here a ratio is a comparison of two quantities. Ratios can be part to part to whole, or whole to part comparisons. Ratios may or may not include units. All right, so let's go ahead and look at our example 1. Example 1 says writing ratios. You have the coins shown. So we see over here some pennies, we see some dimes, I see here quarters. It says write the ratio of pennies to quarters. So we'd have to count pennies first. Well, let's see. 1, 2, 3, 4, 5, 6. So we have pennies is 6. And we do that to quarters. 1, 2, 3, 4, 5, 6, 7. So our ratio would be 6 to 7. Now, if you remember, ratios can be written 3 ways. So you could always write it this way or this way. But the pennies has to come first. All right, the next ratio says write the ratio of quarters to dimes. Well, quarters, once again, we counted 1, 2, 3, 4, 5, 6, 7. So the quarters were 7. And the dimes, let's see if we can find the dimes. Here's 1, 2, and 3. 3 to 7. Now remember, you can't flip it because order matters. We had to do the quarters first. Finally, write the ratio of dimes to the total number of coins, dimes. Well, we just found out right here there were 3 dimes and the total, so we'd have to count all of these coins up. And if I count correctly, it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total coins. All right. Let's go ahead and see if we can fill out these extra problems. Try it. Dimes to pennies. Well, if we remember, there were 3 dimes. And pennies, well, if we remember, we counted up here 6 pennies. Okay, example number, let's do number 2 here with example 1. Quarters to total. Quarters, well, let's see. 1, 2, 3, 4, 5, 6, 7. 7 quarters. Let's see if I can get a writing utensil that works. All right, let's see. We had here 7 quarters to total. Total, we remember we said was 16. 7 to 16. All right, let's go down a little bit farther here. Well, we have a key idea. It says the number A to B associated with ratio A to B is called the value of the ratio. It describes the multiplicative relationship between the quantities in a ratio. A lot of big words. Value is going to be an important word, so we're going to want to circle that. And multiplicative, we want to underline that's going to be a big word as well. Example 2, writing and interpreting ratios. It says here the ratio of rubies, let's underline rubies, to diamonds on a ring is 1 to 2. Find and interpret the value of the ratio. Well, rubies matches with 1. Diamonds matches with 2. And up here, we're going to write it as a fraction. So value is always written in a fraction. And you can see if we only have 1 ruby and 2 diamonds, we would say that rubies are 1/2 of what we have for diamonds. This is called our value. Let's look at B. On another ring, the number of rubies is 4 times the number of diamonds. Write the ratio of rubies to diamonds. Well, since rubies is first, and it says rubies is 4 times as many as the diamonds, 4 times would be 4 to 1. Rubies is 4 times as large as the diamonds. All right, let's look at our try it. An elephant sanctuary contains adult and baby elephants. The ratio of adult elephants to baby elephants is 5:1. Find and interpret the value. Well, when it says the ratio of adults to babies is 5:1, value would be written like a fraction. We'd simplify it to be equal to 5. So here is our value. The answer is 5, meaning the rate that adults are 5 times as many as the babies. All right, let's go ahead and turn over to the back side. All right, remember we're going to continue looking at ratios. Remember ratios are two numbers. It says two ratios that describe the same relationship are equivalent ratios. Two ratios are equivalent when you can multiply each quantity in one ratio by the same positive number to obtain the other ratio. The values of equivalent ratios then are equivalent. All right, well, let's see what they mean by that. So here's our first ratio, 1:3. Okay, so it's right here. Our second ratio is 2:6, right here. We looked to see if we can multiply by the same number. So we took 1 times 2 to get 2. Well, in order for this to be equivalent, we have to multiply by the same thing over here. So 3 times 2, it does equal 6. So these two are equivalent. So if we would do that down here on this one, we would put right here 4 to 3 on top, 20 to 15 on bottom. 4 times what is 20? Go ahead and make your arrow. Well, 4 times 5. In order for these two to be equivalent, this side here has to also be a 5. Well, let's see if that's true. 3 times 5 is 15. Those are equivalent. That is correct. So we could go ahead and just put something like equivalent. All right, now let's determine if these are equivalent. So here we have 5 to 7. That's my first ratio. 10 to 21 is my second. All right, let's see. 5 times 2 is 10. In order for that to be true, this has to be the same thing. 7 times 2, 7 times 2 is not 21. So these are not equivalent. All right. I'd like for you to go ahead and try numbers 4, 5, and 6. If you would be willing to pause your video and then turn it back on so you can check your answers, that would be great practice. So go ahead and pause your video. All right, well, hopefully you paused your video and you're starting it up so you can see we have the ratio 1:1 and 6:6. Are these two ratios, this one equivalent? Well, let's see. 1 times 6 is 6, yes. And 1 times 6 is 6, so these are equivalent. Let's just go ahead and put a smiley face for today. All right, let's check this one here. The ratio 1:2, is it equivalent to the ratio 3:4? Some of you already know. 1 times 3 is 3. 1 times 3 is not 4. This one is not equivalent. All right, next. 8 to 3 and 6 to 16. Let's see. Well, I can't really multiply anything times 8 to get 6 or 3 to get 16. The other thing I notice is this number is larger than the second number, whereas in this ratio, this one's larger and not the first. So this is not going to be equivalent. All right, last examples. Example number 4, modeling real life. Meg is speed walking at a pace of 5 meters every 2 seconds. Sean's pace is 10 meters every 5 seconds. Are they walking at the same pace? So we need to see if their ratios are equivalent. All right, so let's see. Meg is speed walking at a pace of 5 meters every 2 seconds. All right, so meters comes first. Here we have 10 meters to 5 seconds. Okay, well, let's see. 5 times 2 equals 10. 2 times 2 does not equal 5. So are they walking at the same pace? No, they are not walking at the same pace. So go ahead and write your answer for me, please. All right, let's go ahead and see. If not, who is faster? So if we look here at Meg, we're going to go ahead and just put Meg right here. Meg has 5 to 2. And if we take it times 2, she's going to go 10 meters, right? And 10 meters is the same as Sean, okay? So if I take this side times 2, that means I'm going to get 4. So if Meg continues walking 5 meters every 2 seconds, she's eventually going to get to 10 meters every 4 seconds. Well, if she's walking 10 meters in 4 seconds, and we know that Sean is walking 10 meters every 5 seconds, who is faster? Well, it looks like Meg is faster because she can walk the 10 meters in only 4 seconds, whereas Sean has to take the 10 meters and walk it in 5 seconds. So we could say Meg is faster. And I'll go ahead and circle that like that, and you can write that in your notes. All right, number 7. The ratio of wolves to cougars in a forest is 5 to 3. Find and interpret the value of the ratio. Well, value means we're going to write this as a fraction. So the fraction would be like this, 5, and of course 3 on the bottom. When it says to interpret, that means we're going to have to explain. And so we're going to write a sentence here. And so we're going to say the number of wolves, okay, because wolves comes first, the number of wolves is, and our value is right here, 5/3. The number of wolves is 5/3 times the number of cougars. Okay, so here's our first answer. This is our value. Now we had to interpret what that meant. Well, it meant the number of wolves is 5/3 times the number of cougars. This would be interpreting it. We use the value. We had to put the word wolves first because wolves is first in our story and it matches with the 5. If we would have put the cougars first, we would have had to flip our value. All right, let's look at the last problem. You are kayaking at a pace of 63 feet every 12 seconds. Your friend's pace is 21 feet every 3 seconds. Are you and your friend kayaking at the same pace? If not, who is faster? So we have here this ratio, 63 to 12. And then we have the ratio 21 to 3. Now remember, in order for these ratios to be equivalent, we have to multiply by the same number, correct? Well, if I notice the ratio on top is bigger than the ratio on bottom, so I'm going to multiply going this direction. So I know that 3 times 4 is 12. So let's see if I could do the same thing over here. 21 times 4. Oh, 21 times 4, that would be 84. So they're not equivalent. So when it says, are you and your friend hanging at the same pace? We're going to just type here, right here, the word no. If not, who is faster? Well, the only way we're going to be able to compare is we're going to have to make a somewhat of an equivalent ratio or find something that they have in common. And let me show you what I mean. So if I put here, you are traveling 63 feet every 12 seconds. And here is our friend. And the only way I'm going to be able to compare is I'm going to have to look at the friend, which is 21 and 3 seconds. And I need to change either the 21 to 63 or 3 to 12. We need to do something that's going to help me understand this. So what I'm going to do is I'm going to take 21 times 3. If I take 21 times 3, I get 63, which means now I can compare my friend to myself because we both have gone 63 feet. Okay, but let's see. If my friend goes 63 feet, I have to multiply by 3 over here. 3 times 3 is 9. So I can go 63 feet in 12 seconds. My friend can go 63 feet in 9 seconds. So it says, who is faster? Well, you're correct. The friend could get 63 feet in only 9 seconds. So friend is faster. Okay, you can go ahead and turn your video off.